friends. In today's session, we are going to cover all the remaining topics from input output in Java. We will start from the topic that is native methods. So, what are native methods? Native methods are methods from another language that we are merging into our current language. Okay, in short. Occasionally, you may want to it is written in a language other than Java. Such a subroutine or method exists as an executable code for the CPU and environment in which you are working, that is a native code. Okay, so you may want to call a native code subroutine to achieve faster execution time. So for example, if you have written some code in C programming language and you want to use that code in your Java programming language, that method will be called as a native method. Or may you want to use a specialized third-party library such as a statistical package. Okay, so that package may be written in another language other than Java, and you want to merge that package into your current language. So, because Java programs are compiled to bytecode, which is then interpreted or compiled on the fly by the Java runtime system, it would be seen impossible to call a native code subroutine from within your Java program. Okay, so Java programs are compiled first into bytecode, and native code is written in another programming language. But you may think that it is impossible to call a native code that is code written in another language from within your Java program. But unfortunately, this is false. Java provides a native keyword which is used to declare native code methods. That native keyword will be used to tell the Java compiler that this method is written in another language and you are merging it into your language. Once declared, these methods can be called from inside your Java program, just as you call any other Java method. So no need to write that method again in your Java programming language. To declare a native method, precede the method with a native modifier but do not define any body for the method. For example, public why? Because you want to use that method throughout the code. Then native, that this method is native, and then integer method. After you declare a native method, you must write the native method and follow a rather complex series of steps to link it with your Java code. And most native methods are generally written in C programming language. The mechanism used to integrate C code within a Java program is called the Java native interface. Okay, so this interface will be used to integrate your C programming code into Java programming language. Detailed description of the Java native interface is beyond of the scope, but the following description is sufficient information for most applications. The precise steps that you need to follow will vary between different Java environments. Okay, they also depend on the language that you are using to implement the native method. The following discussion assumes a Windows environment. The language used to implement the native method is C. So in general, what is the environment? Windows operating system, and native method is written in C programming language. This type of structure we are going to see to understand how Java native interface is used to implement the native methods in your Java programming language. The easiest way to understand the process is the example, that is native demo. Here we have declared integer I, then main method, then native demo object is equal to new native demo. This class object is created in this class only. Then object.I is equal to 10. Then this is object.I before the native method object.I. Okay, so whatever the modification we are going to do before that, we are going to use it as object.I. Then object.test call a native method. This is object.I after the native method object.I. Then public native void test. Static system.load library native demo. Okay, so this is call a native method. So this is the declaration of native method, public, native keyword, return type, method name, and semicolon. Load a dynamic link DLL that contains the static method, static system.load library, native demo. The test method is declared as native and has no body. Okay, this is the method that we will implement in C shortly. Also notice the static block In static, we are loading the library called native demo. A static block is executed only once when your program begins execution, or more precisely when its class is first loaded, before even the new operator is used. Okay, so it just static block will be called before any object is created. First of all, when your program's execution has started, static block is executed automatically and only once. It is used to load the dynamic link library that contains the native implementation of test. You will see how to create this library. This library is loaded by the load library method, which is a part of the system class. Static void load library string file name. Here file name is the string that specifies the name of the file that holds this library. So static is a keyword, return type, load library, and which library you want to load. So file name will specify the string name of the file that holds the library. For the Windows environment, this file is assumed to have the .dll extension. Compile it to produce native demo.class. You must use the java-h.exe to produce one file native demo.h. Java-h.exe is included in the Java development kit. Okay. So how to compile it? So how to compile it? Compile it to produce the native demo.class. Then you must use the java-h.exe to produce the one file native demo.h. And java-h.exe is included in Java development kit. Native demo.h in your implementation of test method. Okay. So java-h.exe is compulsory and it will produce the native demo.header file. So now to produce this header file, we have to implement this command java-h -jni, that is Java native interface, and name of the class. What is the class name? Native demo. So this is the syntax: Java header file dash Java native interface and class name. This command produces a header file called native demo.h. This file must be included in the C file that implements the test. The output produced by this command is header file. It is machine generated and it will include the Java native interface.h. So you do not have to edit this file. You have it is just for the sake of reference for you. This is automatically generated file and you are not going to produce or edit this file. If not defined, included native demo, define included native demo. If defined C++, extend C. So extend the C keyword, then end if. Class native demo method test signature V. Java native interface export void Java native interface call Java native demo test Java native environment J object. If the define C++ end if end if. Pay special attention to the following line. JNI export void JNI call Java native demo test JNI environment star J object. This will define the prototype for the test method that you will create. The name of the function is Java native demo test. You must use this as the name of the native function that you implement. Okay. So name of the function is Java native demo underscore test. So it is automatically generated Java underscore native demo underscore test. And this is the name. This will the name you will use. You must use this as the name of the native function that you will implement. Instead of creating a C function called test, you will create a one called Java native demo test. The native demo component of the prefix is added because it identifies the test method as being part of the native demo class. Okay. Native demo component of the prefix. Why it is added? Because test is not a simple method here in this case. It is the first of all, it is the native method, and secondly, it is a part of the native demo class. Another class may define its own native test method that is completely different from the one declared by native demo. Okay, so another class that we will create, for example, and it and it and I will create the header file for that particular class. So native methods name that will be generated, this will be very much different from the one declared by the native demo class. Including the class name in the prefix provides a way to differentiate between the different versions. Okay, so if you are providing the implementation details for the test, you will differentiate using the class name. So test method may be in native demo class, test method in maybe the my native class or native one class, any class. So each test method will be differentiated depending upon the class name in the prefix. As a general rule, native functions will be given a name whose prefix includes the name of the class in which they are declared. So prefix will tell us from which class this test method will belong to. After producing the necessary header file by using this method, java h-jni, then file name, you can write the implementation of test and store it in a file called native-demo.c. So include native-demo.h that we have generated, then include java native interface.h, then studio stdio.h, jni export void jni called java native demo test jni environment j object. Then starting the native method. Here we are printing starting the native method. TLS is equal to get object class environment get object. Environment object FID is equal to environment get field ID. CLSII. If FID is equal to 0, would not get field and return. Okay, this is the complete implementation of our method. This file includes jni.h which contains the interfacing information. This file is provided by your Java compiler. Okay, so jni.h is provided by your compiler, the header file we have created earlier. The get object class method is used to obtain the C structure that has information about the class native demo. The get field ID method returns a C struct I for ID name, I for ID name, I for the class. Okay. Get object class will return a C structure that has information about the class native demo. Then get integer field retrieves the original value of the field. Set integer field stores updated value of that particular field. So now we will see the file jni.h for the additional method that handles other types of data. Okay, so Java native interface header file is provided by the Java compiler, and that file may be different from different programmers. Now, after creating this file, you must compile and create a dynamic link library. You do this by using the Microsoft C++ compiler. Use the following command line. So, you in this case you can specify the part2 jni.h in your case and its subordinate file jni.mp.h ci or ld native demo.c. You may or may not require the file path. This will produce a file called native demo.dll. You can execute the Java program which will produce the following output. This is object I before the native method, starting the native method I is equal to 10, ending the native method. This is object I after the native method 20. Okay. So here get integer field will give me the object FID. I value, that is 10. Then after getting that 10, printf, I'm printing this 10 and I'm multiplying this 10 by 2 and then I'm printing the value. So now we will see the problems with the native methods. Native methods seem to offer a great promise because they enable you to gain access to an existing base of library routines and they offer the possibility of faster runtime execution. So already the whatever code that you have already written, you do not need to write it again, and you can reuse it. First, and secondly, you can faster the runtime execution. But native methods also introduce two significant problems: potential security risk. Because the native method executes the actual machine code, it can gain access to any part of the host system. Native code is not confined to the Java execution environment. So Java cannot guarantee that this code is safe and Java only uses that code to execute. Okay. So in this case, security, this is the main part of Java. It cannot be guaranteed by Java. So this could allow a virus infection, for example. For that purpose, applets cannot use native methods because applets are worldwide use. And if the viruses are built in that applet, anybody's structure, Windows structure, or any massive Windows structure can be destroyed. Also, the loading of dynamic link library can be restricted, and their loading is subject to the approval of the security manager. So everything will be checked, and then only everything will be checked by the security manager, and then this dynamic link library will be loaded. And most of the times, or uh, at all, applets cannot use the native method for security purpose. Loss of portability. Because the native code is contained in dynamic link library, it must present on the machine that is executing the Java program. Because everything that you need, that code to be immersed into your Java program must be present on the PC or machine that you are using to execute the Java program. Because each native method is CPU and operating system dependent, each DLL is inherently non-portable. Okay, so every native method, maybe it is written in C or it is written in C++. It is CPU and operating system, that is OS, Windows operating system dependent. For example, each dynamic link library is non-portable. Okay, so it can one dynamic link library is generated in one computer cannot be used in another computer. So portability is one more feature other than security of Java. It is also cannot be implemented. The Java application that uses a native methods will be able to run only on a machine for which a compatible DLL has been installed. Okay. Uh, where your compatible DLL is present, there only you can use these native methods in your Java program. Use of the native method should be restricted because they render your Java program not portable and pose significant security risk in short. Now next keyword is assert. Another relatively new addition is keyword assert. Assert is what it is used during a Java program development to create an assertion which is condition that should be true during the execution of the program. Okay, assertion is in short a condition that should be true during the execution of the program. For example, you might have a method that should always return a positive integer value. Okay, you might test this by asserting that return value is greater than 0 using an assert statement. Okay, your program restricts that some method should always return a positive value, and to be confident about it, what you can do, you can place a keyword assert so that return value will be always greater than 3. At runtime, if the condition actually is true, no other action takes place. However, if the condition is false, assertion error is thrown. That is exception. Assertions are often used during the testing to verify some expected condition is actually met. So what is the difference when you are running it and assert is placed? In our example, if every time that particular value that function is returning is greater than 0, nothing special will happen. But if at any place, if it is returning any value less than 0 or equal to 0, it will show the assertion here. Why then we are using this? We are using this during testing to verify that some expected condition is actually met. They are not usually passed. Used for release code. Okay. Already release code cannot be will not be using this assertion. The assert keyword has two forms. Assert condition. Okay. First form is assert condition. Condition is an expression that must evaluate to a Boolean value true. If the result is true, condition is always returning result, and if the result is true, then assertion is true and no other action takes place. Only it will tell it is true, and if it is false, it will show assertion error. The second form is assert condition : expression. Expression is the value that is passed to assertion error constructor. Okay. This value is converted to its string format and displayed if an assertion fails. Okay. So what is the output of this? If the particular condition is not meeting its particular value, that is, it is giving you a false result, then it will be converted its string format. This expression that we are giving here after : expression, this will be converted to its string format and displayed if an assertion fails. Typically, you will specify string for expression, but any non-void expression is allowed as long as it is finds reasonable string conversion. So whatever expression you will write over here, it is string or it is non-void expression that can be converted to string is allowed. But no other expression is allowed that cannot be converted to string. So the return value of getNum is positive. The program is written over here. Demonstrate assert. Integer value is 3. So now return an integer, static integer getNum. Why static? I don't want data object of this class. Integer getNum, return value minus. First time 3 will be decremented by 1, 2 will be returned, then 1 will be returned, and then 0 will be returned, and so on. So now for I is equal to 0, I less than 10, I plus plus. From 3 to remaining 10 in backward direction will be false. Like n is equal to getNum. So whatever number will be written like 3, 2, 1, 0, -1, -2 will be stored over here. Assert n is equal to 0. Will fail when n is equal to 0. And it will print a value. And when it will fail, it is not greater than 0, it will show an assertion error. To enable assertion checking at runtime, you must specify the --2 option. For example, to enable assertion for assert demo, execute the Java-EA assert demo. Whatever assertion you want to check at runtime, you will specify it like Java-EA assert demo. After compiling and running as just described, the program creates the following output: and is 3, 1, and then assertion error at Java 70. It will give you the line number as same as your exceptions. Repeated calls are made to the method getNumber, which returns an integer value. So from 3 to backward direction, 10 numbers will be called. But since after 1, 0 is equal to 0, that condition is failed, that case, it will give you assertion error. The return value of getNum is assigned to n and then tested using this assert statement. Assert n is greater than 0. Will fail when n is 0. This statement will fail when n equals to 0, which it will after the fourth call. When this happens, exception is thrown. You can specify the message n is negative in this case. You can specify any other expression over here, but that should be non-void, and also it should be casted to a string. Otherwise, it is not allowed over here. For the assertion in the preceding program, when the following output will be generated. Here it will print Java assertion error and is negative that is specified by us. You must not rely on them to perform any action usually required by the program. So you should not be dependent on the assertion. Okay. So assertion will guarantee you that any non-conditional greeting environment is generated. Then it will throw the assert error, but still you cannot rely on them to perform any action. So you should have specified any other way to find out if the condition is actually yes. The reason is that normally release code will be done with assertion disabled. For example, consider this variation of the preceding program who were made to use assert. Class assert demo get a random number generator. Static integer value is equal to 3. Return an integer gets num return value minus. So every time it will return the value, and then n is equal to 0, I is equal to 0, I less than 10, I plus plus. Assert n is equal to get num greater than 0. This is not a good idea. Okay. So every time you are calling this get number and you are checking if this particular get number is greater than 0, this is not a good idea. And then we are printing n is equal to n. In this version of the program, the call to get num is moved inside the assert statement. This is fine if assertion are enabled, but it will cause a malfunction when assertions are disabled. If your code is released, because the call to get num will never be executed. Okay. For non-release code, assertion will happen or executed, and for release code, assertion will not be executed. N must now be initialized because the compiler will recognize that it might not be assigned to a value by the assert statement. So N should be initialized because the compiler will recognize that it might not be assigned a value by the assert statement. Assertions are good addition to Java because they streamline the type of error checking that is common during the development. Okay. So every time it will check the if particular condition is met or not. For example, prior to assert, if you wanted to verify that n was positive in the preceding program, you had to use a sequence of code similar to this. So if n is greater than 0, n is negative and return. But if you are writing in this such a way that if you are calling every time get number and then you are creating the n, and this n you are not initializing, so it will throw an error. Okay, so this is not allowed. This is okay. In opening and closing braces, you are providing sequence of statements are you are trying to execute if n is less than 0. With assert, you need only one line of code. You don't have to remove assert statement from your release code. Okay, release code will not use the assert statement, but you don't have to remove this. Okay, so in this case, this will not. Okay, this is actually works for non-release code, but if release code, assert will be skipped. So in this case, this statement will not be executed and will give you error. Assertion enabling and disabling option. You can disable assertion using -da-da option. You can enable or disable specific package by specifying its name after the -da or da option. For example, to enable assertion in a package called mypack, use -da:/mypack. To disable assertion in mypack, use -da mypack. To enable all subclass packages, follow the package name with 3 dots. Okay, so complete package if you want to enable or disable, you have to give 3 dots. You can also specify class with the -da or -da option. Okay, -da assert demo. So here you are giving the particular class name. Here you are giving a complete package. Here you are enable assertion in a package that is mypack. Here you are enabling disabling assertion in a mypack. Now static input. JDK 5, that is Java 5, added a new feature called static input that expands the capabilities of the import keyword. By following import with keyword static, an import statement can be used to import the static members of the class or interface. Import the static members of the class or interface. Okay. Input and static combination is importing static members only. When using a static import, it is possible to refer to static members directly by their names without having to qualify with the name of their class. Okay, so if your import is static, then you can whatever static variables like static integer, static float, static double, static method, and static doc, anything, you can call it directly without using the class name. This simplifies and shortens the syntax required to use the static member. To understand the usefulness, we will see the example hypotenuse of the right triangle triangle. It uses two static methods from class math. It's part of Java.lang. The first is math.power, which returns a value raised to a specified power. And second is math.square root, which returns the square root of its argument. Hypotenuse, double side 1, side 2, double hypotenuse. Side 1 is 3.0, side 2 is 4.0. Notice how square root and power must be qualified by the class name, which is math. Math.square root, math.power, side 1, comma 2, math.power, side 2, comma 2. Because power and now given side of length, side 1 and side 2 is the hypotenuse is calculated over here. Okay. Square root of side math.power side 1, 2. First side square plus second side square, and its square root is hypotenuse. Because power and square root are static methods, they must be called the use of their class name math. This result is somewhat unwieldy hypotenuse calculation. So every time power and square root, you have to specify it like this. Its class name math. Math.power, math.power, here also math.square. And when you are implementing it with sine, cos, and tan, this can use row tail. You can eliminate the tedium of specifying the class name with the use of static input, as shown in the following version of the preceding program. Import static java.lang.math square root. So whatever static members are written here in this package java.lang.math square root class, every member can be used directly without using this math dot. Okay, so math dot is skipped over here. Here also java.lang math.power, you can whenever you are going to use the members, you can skip the math dot. Compute the hypotenuse of the right angle triangle. Class hypotenuse, double side 1, side 2. Side 1 is 3.0, side 2 is 4.0. Hypotenuse is equal to square root power side 1, 2. So here math dot is skipped. Here also math dot power is skipped. Math dot power. So math dot is skipped over here. You can directly use the square root method, which is the static method of the class math. Power also static method of class math. Is this also static method of class math? Given sides of length side 1 and side 2, its hypotenuse is hypotenuse. Okay. Then square root and power are brought into view by the static input statement. Import static java.lang and square root and power. After this statement, it is no longer necessary to qualify square root or power with their class name. Okay. So calculation is as simple as that. There are two general forms of import static. The first, which is used by the preceding example, import static package type name or static member name. Here type name is the name of the class or interface that contains the desired static member. Full package name is specified by package. The The name of the member is specified by static member name. The second form of static import imports all static members of a given class or interface. Its general form is shown here. Import static package type name dot star. Okay. The second form is import all static members of a given class or interface. Static package type name dot star. If you are giving star, all static members will be imported if you are needing it or not. If you will be using in many static methods or fields defined by class, you can give a star. Then this form lets you bring them without having to specify each individual. Okay, like you are importing package name dot star, all the classes will be imported from that package. The same way, import static package dot type name dot star will be importing all the static members. So you need not write each and every static member's name by its individual. Therefore, the preceding program could have used this single import statement to bring both power and square root and all other static members of math into view. Import static java.lang.math. In some cases, maybe you are not known to which member you are going to use. For example, so you can use this format like import static java.lang.math.star. So all static members will be imported, and if you are directly pressing the space, you will be prompted with all the possible static members from that class. So you no need to remember or no need to Google or no need to find out which static members I'm going to use in my Java program. Of course, static import is not limited just to math class or just to methods. System.out import static java.lang.system.out. After this statement, you can output the console without having to qualify output the system. Out.println after importing system.out, you can use out directly. Okay. So static import. So out is a static member of class system. So you can directly specify out.println. Whether importing system.out is just or is a good idea is the subject of debate. Although it does shorten the statement, it's no longer instantly clear to anyone reading the program that out being equal to its system.out. Okay, so not everybody is known to this static import. So whoever is known to this, you can use it, and otherwise you can directly use like system.out as usual. In addition to importing the static members of classes and interfaces defined by the Java API, you can also use static input to import the static members of classes and interfaces that you create. It is important not to abuse it. The reason that Java organizes its libraries into packages is to avoid namespace collisions. Okay. So to avoid namespace collision, Java organizes its all libraries into packages. When you import static members, you are bringing those members into the global namespace, and everybody can reuse it, and anybody can abuse it also, and which is not expected. If you are increasing the potential for the namespace conflict. Okay, you can have the test method from the class 1, you can have the test method from the class 2, and so on. So there can be a namespace conflict, and we should not be arising. And for that, inadvertent or hiding of other names, and which is not expected. So when you are having complex expressions like we have calculated the hypotenuse of the right angle triangle, in such cases you can use this static import, but in cases like namespace collision can occur, you better avoid using this import static. If you are using a static member once or twice, it's best not to import it. Also, some static names such as system.out are so recognizable that you might not want to import them. Okay, system.out, we have practiced it a lot. So we always write it like system.out only. So you might not want to import it. Static import is designed for those situations in which you are using a static member repeatedly, such as when performing a series of mathematical computations. Okay, but it is for uses and not for abuses. This feature. Invoking overloaded constructor through this. working with overloaded constructors, it is sometimes useful for one constructor to invoke another. In Java, this is accomplished by using another form of the this keyword. Okay, so how to overload a constructor from the same class or from the superclass? This is accomplished using the this. The general form is this argument list. When this is executed, the overloaded constructor that matches the parameter list specified by the argument list is executed first. Okay, so whatever overloaded constructor when this is executed that exactly matches the parameter with the called argument list is executed first. Then if there is any statement inside the original constructor, they are executed. The call to this must be the first statement within the constructor. Okay, so whatever constructor you are overloading, call to this should be the first, must be the first. To understand how this can be used, let's work through a short example. First of all, we will see which does not use this integer. In my class, there are two integer variables a and b. Initialize a and b individually. My class integer I, integer j. A is equal to I, b is equal to j. Initialize a and b to the same value. My class integer I, a is equal to I, b is equal to I. Then this is the initialization operation. Give a and b default values to 0. My class with no parameter default constructor a and b is equal to 0. This class contains three constructors, each of which initializes values of a and b. The first is passed individual values for a and b. Okay, I, j. Two parameters a is equal to I, b is equal to j. Second, one parameter a is equal to also I, b is equal to also I, and third is with no parameter a is 0, b is 0. Okay, so using this is possible to rewrite this class like initialize a and b individually. I, j, I is equal to I, b is equal to j. Then initialize a and b to the same value. This I. Okay, so this I invokes my class of I. Then this 0 invokes my class of 0. In this version of my class, the only constructor that actually assigns values to a and b fits my class int a. Okay. Only two parameters constructor it will be called over here. In this version of my class, the only constructor that actually assigns value to the a and b is my class int a. The other two constructors simply invoke that constructor either directly or indirectly through this. For example, consider what happens when this statement executes. Class MC is equal to new my class 8. Okay. Other two constructors simply invoke that constructor through this. Class MC is equal to new class 8. The call to my class 8 causes this 8 to be executed, which translates to a call to my class 8 because this is the version of my class constructor whose parameter list matches the arguments passed via this. Now, class MC2 is equal to new my class. This of 0 is called. This causes my class 0 is invoked by because this is the constructor with the matching parameter list. My class for this is 8 to be executed, which translates into false. My class 8 because this is the version of the my class constructor whose parameter list matches the argument passed by this. So class MC2 is equal to new my class. In this case, this of 0 will be called because default constructor is being called. This causes my class 0 to be invoked because the constructor with the matching parameter list 0 means no parameter, that is default constructor. My class 0 then calls my class 0 as described. Why invoking overloaded constructor through this can be useful is It can prevent unnecessary duplication of the code. In many cases, reducing duplicate code decreases the time it takes to load your class because often the object code is smaller. So unnecessary duplication of code is avoided using this, and reducing duplicate code decreases the time. That is, the time complexity is saved. It takes to load your class because often the object code is smaller. Okay, so duplication is not allowed, not actually required in many cases, and the time required for duplicate code is eliminated using this. This is especially important for programmers delivered via the internet, in which load times are an issue. Using this can also help structure your code when constructors contain a large amount of duplicate code. Okay, internet code in internet actually data transmission actually always taking time. So avoid the time complexity, that is added overhead, added extra, that is eliminated using this. And this can also help structure your code when constructors contain large amount of duplicate code. So again and again calling the same code is avoided using this. You need to be careful. Constructor that call this will execute bit slower than those contain all of their initialization code in them. This is because the call and return mechanism used when the second constructor is invoked adds overhead. Okay, so it is also calling taking extra time for switching between one code to another code. Calling one constructor from another constructor, it will add the bit overhead. If your class will be used to create only a handful of objects or the constructor in the class, that call this will be seldom used, and this will be the runtime performance is probably insignificant. Okay. That is, you are creating only a handful of objects or of the constructor in the class, that call this will be seldom used, very rarely used. Then this decreases the runtime's performance. If your class will be used to create a large number of objects during your program execution, then the negative impact of the increase overhead could be meaningful. Because object creation affects all users of your class, there will be cases in which you must carefully weigh the benefits of faster load time against the increased time it takes to create the object. For very short constructors such as those used by my class, there is often little difference in the size of object code, whether this is used or not. Okay, so here there were only 3 constructors. So here we did not understand actually we are using this or not, because the code is very short. There are cases in which no reduction in the size of the code, object code is actually achieved. Okay, we are telling that this is reducing your time complexity, but in many cases we do not understand actually we are using this or not, and actually it is saving our time or not. This is because the bytecode that sets instructions adds instructions to the object file. So same overhead will be generated at this time. Therefore, in these types of situations, even though duplicate code is eliminated, using this will not obtain significant savings in terms of load time. So we do not understand actually we are using it or not. However, the added cost in terms of overhead to each object construction will still be incurred. Therefore, this is most applicable to constructors that contain large amounts of initialization code, not for those that simply set the value of handful of bits. Okay, so very simple constructor that have 2 to 3 parameters that can be generated or that can be set using the simple parameterized constructor, then it is okay. You cannot use this over there because it is not useful. But in that cases where there are multiple parameters present, in that case you can use this. There are 2 restrictions you need to keep in mind when using this. First, you cannot use any instance variable of the constructor's class in a call to this. First of all, you cannot use any instance variable of the constructor class in call to this. You cannot use super and this in the same constructor because it must be the first statement in a constructor. Okay. First of all, you cannot use any instance variable of the constructor class in a call to this, and second super and call super and this cannot go hand in hand. So this way we have completed the input output in Java theory part 3. In the next session onwards, we will start with the practical part and understand how input output actually happens in Java. So, meet you in the next session for the practical part. Thank you so much.